expression for angular momentum in terms of polar coordinates. My dear students, the derivation of this will take the same step as is done in the derivation of torque in terms of polar coordinates. See here we have replaced the force with linear momentum P. This is the point P having coordinate x and y. This angle phi is with the made by momentum with the position vector, and alpha is the angle made by linear momentum with the x-axis. Okay, so now we came to know that momentum is equal to xpy minus ypx. Okay, now resolving, we know that x is equal to r cos theta and y is equal to r sin theta. Okay, x is equal to r sin cos theta and y is equal to r sin theta. Similarly, px angle made by linear momentum with x-axis is alpha. So px is p cos alpha. So this is p cos alpha, and py is equal to p sin alpha. Putting these values in this expression, p is equal to x is r cos theta p sin alpha minus this is y is r sin theta into p cos alpha. So taking rp common, this is sin alpha cos theta minus sin theta cos alpha. So the formula for this will be rp sin of alpha minus theta. Okay, now we can use the property that sum of internal angles is equal to external angle. So accordingly, theta plus phi is equal to alpha, or phi is equal to alpha minus theta. So putting this value in this expression, we will be having p is equal to rp. This is sine of phi, right? Or we can write this as r cross p. This is angular momentum, so this is represented by L. So L is equal to, this is L is equal to, so L is equal to R cross P. So the direction for L as well as torque is given by right hand screw rule and is perpendicular to the plane containing R and P. Now again, draw perpendicular from O to the line of action of linear momentum. So accordingly, sin phi can be calculated. This become base, this is perpendicular, and this is hypotenuse. So in that case, sin phi is equal to perpendicular upon hypotenuse. So sin phi, we can write sin phi is equal to perpendicular is ON upon hypotenuse is OP. Okay, so in that case, ON perpendicular, this is ON is equal to R sin phi, where OP is R. So putting the value here, this is L is equal to R sin phi into P. So we can write P into ON. That is, angular momentum is the product of linear momentum and the perpendicular distance between the line of action of force of the linear momentum to the line of action of force. So this is the expression for torque in the polar coordinates.